What's up, sixth grade class? This is Mr. Van Note, and this is your Unit 3 mid-chapter test review. There's going to be 8 practice problems, and at the end, there's 2 other problems that are 100% on the test. All right, there's 7 questions on the test, and 2 of them, I'm telling you exactly what they are, not the numbers, but what they are. So the other 5 are going to be in this review. Please study and watch this and do your best job tomorrow. All right, let's get into it. All right, howdy kiddos. Welcome to the mid-topic checkpoint for topic 3. So this is going to go over lessons 3.1, 3.2, and 3.3 in 8 questions. And at the end, I have a couple more questions that are going to be relevant to the mid-chapter test on Friday. All right, but first let's go over the vocab section. So it says, describe the relationship between the base and the exponent. So the base and the exponent in 4 to the power 3. So 4 to the power 3. First, remember that the number that's being multiplied by itself is the base. And how many times it multiplies itself is the exponent. So that's pretty much the relationship. The exponent tells you how many times the base multiplies by itself. So if I have 4 to the power 3, that means I take the base 4 and I multiply it by itself 3 times. All right? So this exact question isn't going to be on the quiz or anything like that, but there is a question where you need to know how bases and exponents work. But it's not too hard. So if you know that 7 times 7 times 7 times 7 equals 7 to the power 4, you're good. And you got one question out of 7 right. So remember, the base is the number being multiplied. And the exponent is how many times it's being multiplied. So this is 7 multiplying itself 4 times, or 7 to the power 4. All right, question 2. What is the GCF of 14 and 42? So GCF is the greatest common factor. So it's the biggest number that I can multiply and get 14, and I can also multiply that same number and get 42. Now the way we do this is we get the prime factorization of both numbers separately. So what 2 numbers multiply to be 14? Well, it's going to be 2 times 7 is 14. 2 is prime, so I circle it. 7 is prime, so I circle it. I got both sides circled, so I'm done. 42, that's going to be 2 times 21. 21 is prime, so I'm done with the left side. But 2 is prime, but 21 is composite. So I can still multiply to get 21. So what 2 numbers multiply to get 21? 3 times 7. 3 is prime, circle it. 7 is prime, circle it. And now I'm done. So this is the first step. Get the prime factorization of both of the numbers. The second step is to see what these 2 numbers have in common. And the way I do it is I like to be organized. And I'll write 14 equals 2 times 7. So I'll write the prime factorization for both numbers. And I'll write them nice and orderly. All right, now look, what do they both have in common? Well, they both have a 2. So I'm going to write for the greatest common factor, there's a 2. They both don't have a 3, but they both have a 7. So I'm going to put 2 and a 7 and multiply them. And that's all they have in common. That's all they both have. And 2 times 7 happens to be 14. So this is the greatest common factor. So remember, 2 steps for the greatest common factor. Prime factorization of both numbers, and then circle what they have in common. Do not mix up the greatest common factor with the least common multiple. We're going to go over that on the next slide. So please, please, please don't mix those two up. All right, question 3 is very similar. It says, which one of these numbers, these pairs of numbers, has a greatest common factor of 5? Well, we got to find the greatest common factor for all of them until we find one pair that has a greatest common factor of 5. So let's do them all. So start with A, 15 and 30. I know 15 is 3 times 5. 3 is prime, 5 is prime. I know 30 is 2 times 15. 2 is prime. And 15 is 3 times 5 again. So I look, what do they have in common? They both have a 3, and they both have a 5. So the greatest common factor for this one is going to be 3 times 5, which is 15. So it's not A. Let's look at B. 5 and 21. And also, let's write on the top some prime numbers. So just try to memorize these. So you know that if you see these numbers, you're going to circle them. So 2, 3, 5, 7, 11. I'd stop there. You probably won't go past 11 on a 6th grade test. So if you see a 2, 3, 5, 7, 11, right away, circle them. So right away, we start with a 5. That's prime. Circle it. And 21, we already know that's 3 times 7, which are both prime. So they don't have anything in common. This only has 5, and this has 3 and 7. So when they have nothing in common, their greatest common factor is going to be 1. So B is out of the question because it's not 5. All right, let's try C. 45 and 9. Well, 9 is 3 times 3, both prime. 45 is 5 times 9. 5 is prime, and 9 is 3 times 3. So these both don't have a 5, but they both have 2 3s. So here, the greatest common factor is 3 times 3, or 9. So from here, I can confidently say the answer is D. But let's do it just to prove it. So here we have D. We have 20 and 55. 20 is 4 times 5. 5 is prime. 4 is 2 times 2. 2 is prime. And 55 is 5 times 11. Both prime numbers. We look. This side has 2 2s, but this has no 2s. So 2 is not a common factor. But they both have a 5. So the greatest common factor is 5. And that is our answer. All right, hopefully this helps you know how to get the greatest common factor and helps remind you how we get exponents. So how we can write a repeated multiplication of the same number as a base and an exponent. Now the next slide, we're going to go over some calculator work, and we're going to go over the least common multiple, both of which are on the quiz or the test. All right, let's get to it. All right, question 4. What is the least common multiple, the LCM, of 12 and 9? So please, a lot of you on the last quiz, when it asked for the greatest common factor, you did the least common multiple instead. So please take a moment, go over the difference between the two. So the least common multiple means I got to find the multiples of both the numbers they give me. So in this case, 12 and 9. And I got to see what is the smallest multiple that they both have in common. So what number is in both of these lists? Now remember, a multiple of a number is that number times 1, times 2, times 3, times 4. And we just write out all the numbers, just like we learned in our multiplication tables. So it's pretty much all at once. So I'm going to write the multiples of 12. So I got 12 times 1, 12 times 2, 12 times 3, 12 times 4, 12 times 5, 12 times 6, and so on. 72, 82, 84, 96, dot, dot, dot. Now let's do 9. We do 9 times 1, 9 times 2, 9 times 3, 9 times 4, 9 times 5, 9 times 6, 9 times 7, 9 times 8, 9 times 9, and so on. Then I look and I see what number is in both of these lists. So if I go from high to low, which you shouldn't do because you can make a mistake, and I'll show you that now. So 81 is not in both. 72 is in both. Oh, great. The least common multiple is 72, right? No, because there could be a smaller number they both have in common. And if we keep going down the line, I can see that they both have 36 in common. 36 is less than 72. So 36 is going to be my least common multiple. Also, that's why when you're starting to look for the least common multiple, always start from the small numbers and go higher. That way, you'll come across the correct one, the lowest one first, and you don't have to keep looking. All right, so just a little trick. Always start with the lowest numbers, so you won't make that mistake. All right, question number 5. Evaluate numerical expression. This one is why you need a calculator, because you can plug this straight into the calculator and you get an answer. But if you don't have a calculator, I taught you how to do this by hand, so you must do it by hand. So 0.5 times 0.5, what is half of 0.5? Well, that's 0.25. I'm going to do my exponents first, because remember, we're always going to use PEMDAS. We do what's in parentheses and exponents. So I have 20 minus negative 2 squared. Negative 2 times negative 2 is 4. I have a times 3. This is 2/5 times 25. If I put that in my calculator, which is my head, I get 10. 25 times 2 over 5 is 50 over 5, which is 10. Then I go through it again, and I do the parentheses. So I get 0.25 times, in the parentheses, I multiply first. 4 times 3 is 12. 20 minus 12, 8. And I have it times 10. Then I keep going, left to right. I have 0.25 times 8. And if I do the math on that, that gives me 2. So 0.25 times 8 is 2. And I have this times 10. And 2 times 10 is 20. So you can do it like I did using PEMDAS and your thinker, or type it in the calculator. All right, question 6. Select all expressions that are equal to 2/3 to the power 2. So when it says select all expressions, that means it's very likely that we will have more than one answer, and we can have more than one answer. So first, I want it to be equal to 2/3 squared, or 2/3 to the power 2. So 2/3 to the power 2, I take the base, 2/3, and I multiply it by itself 2 times. All right, 2 times 2 is 4. 3 times 3 is 9. So I'm looking for expressions that are equal to 4 over 9. And my first option is 4 over 9. Well, obviously that's the same as 4 over 9. What about 4 over 3? No, 4 over 3 is not the same as 4 over 9. 1/3 times 1/3. Well, let's multiply. 1 times 1 is 1. 3 times 3 is 9. 1 over 9 is not the same as 4 over 9. And I have 1 over 9 times 4. I turn that 4 into a fraction, make it 4 over 1. 1 times 4 is 4 over 9 times 1, 9. So yes, this one works. And then finally, I have another fraction, 2/3 times 2/3. Well, that's exactly what 2/3 square is. 2 times 2 is 4. 3 times 3, 9. So those three checked ones are all equivalent or equal to 2 over 3 squared. And you could have also used a calculator for this one, but you don't need a calculator for anyone. So if you didn't buy a calculator after me begging you for 3 weeks, even though it doesn't benefit me whatsoever, I beg to help you. I want you to do good. It doesn't help me, it helps you. So if you didn't do one, it's still possible to do it without the calculator. Alrighty, we have 2 more questions and then just a little question or two for the last slide. That's not part of this review, but you need to know it, trust me. All right, 7. Liam bought 2 vintage movie posters, and then he got 2 rock posters, and he got 1 rap poster. All right, sweet. He applied a $35 gift card to the total purchase, and he had a half off coupon to the rap poster. That's a pretty good deal. So now it says, write and evaluate a numerical expression to show how much Liam paid for the poster. So when it says write and evaluate a numeric expression has numbers like 3 and 4, and it has an operator somewhere in between them. So an operator, remember, are add, subtract, multiply, and divide. So any numbers with an operator is a numeric expression. All of these are numeric expressions. So pretty much they want us to turn this word problem into math, or a numerical expression to be more precise. So we have 2 vintage movie posters. So let's see how much this guy paid. So movie poster is $28.80 for one poster. And remember, the amount you pay is the cost of the item times how many you bought. So Liam bought 2 of them at $28.50. Multiply those two, and that's how much he paid. Next, he got 2 Rockstar posters. Well, rock posters are $29.75, and he also got 2 of those. So 2 times $29.75 is how much he paid for the rock posters. So let's write this down. So we have rock, we have vintage, and then we have a wrap poster. And he got 1 wrap poster, which cost $19.50. Now, there's a caveat with the $19.50, because this is the wrap poster. And it says he has a half off coupon for the wrap poster. So he's not going to pay full price for one poster. He's going to pay half of one poster. So instead of 1 times 1950, it's going to be 1/2 times 1950. Well, this is how much he paid for the vintage. This is how much he paid for the rock. And this is how much he paid for the rat. To find out how much he paid for all of them put together, we simply add them all together. So let's do that. 2 times 2850 is going to be 28 plus 28 is 56. And 50 cents plus 50 cents is 1. So this is going to be $57 even. Plus 2 times 29.75. That's going to be 30 plus 30 is 60 minus 50 cents. It's going to be 59.50. And then we're going to see how much half of 1950 is. So 1950, half of that. I'll do this because remember, finding half of a number is the same as dividing it by 2. So 2 goes into 19. How many times? Well, it's going to be 9 times. 2 times 9 is 18. So we subtract, we get 1. And we can bring down the 0.5. So we have 1.5. So 2 goes into 1.5. How many times? Well, 2 is too big for 1.5. So I add a decimal, and I can add a 0. So 2 goes in to $1.50 how many times? Well, let's see. Oh yeah, it's $1.50 anyway, so yeah. So 2, 4, 6, 8. So it's going to be 9, 7. Give me the 14. I have the 1, 0. 2 goes into 10. 5 times. And we are done. So the wrap poster is $9.75. So adding all of these together, we get $59.50 plus $57 plus $9.75. And make sure you line up your tens, tenths, your hundredths, your ones, and your tens. Remember, you got to line everything up when we're adding decimals. And if you like, you can put zeros in the missing spaces. So 975 is the same as 0.975. Now let's add 0, 0, 5. 5 plus 0 plus 7 is 12. Bring down my decimal, carry the 1. 9 plus 1 is 10. Plus 7 is 17. Plus 9 is 26. Carry the 2. 5 plus 5 plus 2 is 12. So his total was $126.25 for 2 vintage posters, 2 rock posters, and 1 wrap poster that was half off. We're almost done because he is going to use his $35 gift card. So if we subtract $35 from the gift card, we find out how much cash he paid for it. So we're going to subtract the $35 from $126.25. Remember, we have to line everything up. The hundredths, the tenths, the ones, the tens, the hundreds. All right, 5 minus 0 is 5. 2 minus 0 is 2. Bring down the decimal. 6 minus 5 is 1. And 2 minus 3 is too big. So I borrow 1 from the hundreds. And 12 minus 3 is 9. So in total, Liam spent $91.25 in cash, including his half-off coupon and including his $35 gift card. And let's just write that here. Subtract gift card. All right. So once again, you can do this by hand. If you had a calculator, so much easier. So 8, last question for the review. Eva counts by 3s, while Jin counts by 5s. What is the least number that they both say? So Eva counts by 3s. Oh, so it's not 3s. I think they mean by 3s. And Jin counts by 5s. What is the least number that they both say? Okay, so Eva, if she counts by 3s, she's going to say 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and so on. And Jin counts by 5s. So Jin's going to say 5, 10, 15, 20, 25, 30, 35, 40, and so on. Now we got to look at the lowest common multiple. So this is just a fancy way of saying what's the lowest common multiple between 3 and 5. So remember, we want to look from the low side to the high side, see what they both have in common. So they both don't have a 3. They both don't have a 5. Both don't have a 6. Both don't have a 10. Both don't have a 9. But they both have a 15. Hooray. So 15 is going to be the first number, the least number, that they both say out loud. All right, how well did you do on this mid-topic checkpoint? Psh, give myself 1.5 stars. Easy. Go me. Go Mr. Van Note. Awesome. Woo. All right, so please don't skip now. Wait, you got to see the next slide because this is on the test for sure. Please pay attention. All right, next one. Hello, my name is Archie, and I'm the cutest dog in the world. Hey, I want to say hi to Archie. You want to say hi real quick? All right, back to work. So, special considerations. All right, like I mentioned before, please know how to do exponents. Please be able to turn repeated multiplication into a base and an exponent. Remember, the number that's being repeated many times is your base. And how many times they get multiplied by is your exponent. You need to be able to turn this into this on the test. All right, 5 times 5 times 5 times 5 times 5 times 5 times 5 is equal to the number being repeatedly multiplied is my base. And it's 1, 2, 3, 4, 5, 6, 7 times 5 to the 7th power. Need to know that. Also, there is one question on the test, just like I put it on the vocab quiz, where it's something like, here, let me make one up. Use the greatest common factor to reduce this fraction. So this is going to have 3 steps to it. First step is I find the greatest common factor of 12 and 36. So 12 is 2 times 6. 2 is prime. 6 is 2 times 3. 2 and 3 are prime. 36. This is going to be 2 times 18. 18 is 2 times 9. And 9 is 3 times 3. Circle my prime numbers. All right, step 1, same. Step 2, I line them up. 2 times 2 times 3. And 36 is 2 times 2 times 3 times 3. All right, Also notice that on the quiz, on the test, instead of writing 2 times 2 times 3, well, they might write 2 squared times 3, because 2 times 2 is 2 to the power 2. And for this one, we have 2 to the power 2 times 3 times 3, which is 3 to the power 2. So they might write this both ways. Don't be freaked out if you see exponents there, because you can always turn exponents back into multiplication. Remember, 2 to the power 2 is just 2 times 2. 3 to the power 2, just 3 times 3. 3 to the power 4 is just 3 times 3 times 3 times 3, 4 times. So no big deal if they do that. But now let's find the greatest common factor between these two numbers. They both have a 2. They both have another 2. They both have a 3. But that's it. They both don't have 2 3s. So my greatest common factor is just what they both have in common, which is 2, 2, and 3. 2 times 2 times 3. And what number is this? 2 times 2 is 4. 4 times 3 is 12. This is my greatest common factor. Now, the last step is we have to simplify that fraction. So I rewrite the fraction, and I divide the top and the bottom, the numerator and the denominator. I divide both of them by whatever my greatest common factor was. Here, my greatest common factor was 12. So the extra step is I now divide my fraction by the greatest common factor. 12 divided by 12 is 1. 36 divided by 12 is 3. All right? I think this is exactly the one I gave you on the vocab quiz too, by coincidence. All right, so I want to make sure that you know these two as well. So if you know those 8 questions we just did, you have a calculator, and you know how to do these two problems, you're going to get an A on this test. So please do your best. Please watch this video, and please have a calculator. All right, you guys, good luck tomorrow, and happy almost Friday. Bye-bye. Archie says bye as well.